you have to realize, are you an analytical, like read a book kind of coder, or are you someone that has to go in and experientially find your way through things and like experience how the system works and then kind of get a better sense that way. So that'd be the first thing. And then the second thing is just trying to ignore as much noise as possible and follow your curiosity. So the more curious you are and the more persistent you are about pursuing your curiosities, it's going to give you a much better chance at learning some pretty wild stuff that will actually end up either getting you hired or building your next project. So I would just say, like, I learned all this stuff because I was very curious about what was possible. Like, could you build some kind of layer on Ethereum that could transact, but that retained the securities? And that was sort of the question you ask. And the answer is, well, yes, in theory, but now you got to go do it. So then you work with a few people and you actually go do it. And then you go, okay, wow, no, that's possible. So then what else is possible?
Hello and welcome to another episode of Devs Do Something. Today's guest is Nick Dodson, a co-founder at Fuel Labs and one of the creators of the Sway language. This episode is a really interesting one for me because before doing the research for this episode, I didn't know much about Fuel outside of what I learned to prepare for a podcast with Cami, who leads developer relations at Fuel. If you haven't seen the Cami episode, I highly recommend you checking that out. We'll put a link in the show notes. But this one goes very deep into Sway and the Fuel toolchain and some of the decisions they've decided to make on the actual protocol level, right? So Fuel has approached the problem of scaling blockchains in a unique way. They've built what they call the world's fastest modular execution layer, and they have focused very aggressively on developer experience. So in this episode, we go through what Sway is, their domain-specific language, how it works, some of the various particulars of the language. I played around with Sway before we did this episode, and I was impressed and was able to ask some interesting questions, I think. We also talked through some of the things that Fuel has done at the actual protocol level, right? So they have a list in their docs of EIPs that have been implemented in Fuel that have not yet been implemented in the EVM, right? And I think that the team has been able to innovate with the blank slate in a very interesting way. The Fuel team is honestly kind of stacked. They have quite a few gigabrains on staff, and it makes sense when you look through their DevX and their docs and what they're actually working on here. So this episode, again, was very interesting. Nick is an inspiring guy. He said some things with regard to like how to approach your career as a developer, how to level up, and how to think about things in crypto for the long term that I think a lot of people are going to enjoy. There are things that resonated with me. And yeah, I think if you're Sway pilled, you're going to love this episode. It'll give you some good confirmation bias. If you don't know anything about Sway or Fuel, this is a great introduction. And we really appreciate Nick and Cami a couple weeks ago for coming on to spread their knowledge about Fuel. So with that, I hope you enjoy the episode. Are you a DAO or crypto native business with salaried employees? Or do you perhaps work for one? If so, whether you're a team of 5 or 500, your organization can save time and money by streaming salaries with Superfluid, who also happens to be the beloved producer of this podcast. With salary streaming, your management team no longer has to worry about executing multi-sig operations every month or manually executing hundreds of separate transactions to pay their team. Contributors and employees, on the other hand, get paid by the second, which, to be honest with you, is a pretty killer benefit on the receiving end. Those of us getting paid via stream can connect our wallet to the Superfluid dashboard and see our balances ticking up in real time. It's kind of mesmerizing and feels like you're being jacked 10 years in the future. When you're paid in a stream, it flows in perpetuity until your team needs to adjust compensation, which effectively puts Web3 payroll on autopilot. Salary streaming is easy to set up thanks to our recent integration with CoinShift, the leading crypto treasury management platform. In just a few clicks, you can securely set up payroll for hundreds of employees in just a single transaction, all from CoinShift's dashboard. If this sounds like something you're interested in exploring, you should visit superfluid.finance/payroll and book a salary streaming demo today. Thanks to all of our sponsors. let's get on to the episode. All right, so we're here today with Nick. Nick, thank you so much for being here, man.
How's it going? Yep. Thanks for having me.
Yeah, fantastic. Yeah, I think this is going to be a really, really awesome episode, just on all things fuel and sway, especially on the technical side of things. But before we get into all of that stuff, the first question we'd love to ask is how people got involved in the industry. So love to understand just how you got involved in crypto in general.
Yeah, for sure. So I started with crypto in around 2013. Initially, I was doing a lot of mining. That's kind of where I began, just like buying GPUs, clearing out all the stores of GPUs, and running mining rigs in my basement. And I was shipping. I'm Canadian, so I was shipping cold air into my house, and then I was heating my house with the mining heat, and it was really hot down there. It was extremely hot. I'd have to keep them running sometimes with very little clothing on, and my friends thought I was crazy. They thought I'd lost it. It looked pretty nuts. But that's sort of where I started, and then after that, wanted to start working on mining aggregators. So just running a bunch of like P2 pool stuff, and it was real early days kind of thing. And then from that point, started reading the mining code and realizing that mining was a little ridiculous. The code was just doing arbitrary hashing. I didn't really look at it before, but once I actually figured out more about just how blockchains worked and how mining worked, I thought, well, it's not really a great use of my time or my energy. So I started to look at how I could build things on Bitcoin or build things on some of these systems, and basically things were pretty basic back then. I looked at the Bitcoin client. I spent a little bit of time there. I wanted to do more stuff with the op return, so just like their arbitrary data. So I posted in the Bitcoin forum, like, expand the op return from 40 bytes, whatever it was, to 1 megabyte. And then that was like right in the heat of I think the block size wars, it was around that time. And just I've just never been so attacked on the internet. Like, I just had no idea who these people were. I had no idea what was going on. And then some guy at the very end of that thread, it's probably still there somewhere, was like, oh, you should check out Ethereum. And then just my whole life shifted after that point. So it was very, very wild. Then I started to work with Ethereum. I built some of the first, apps on Ethereum, and was one of the first users of Solidity. So we're starting to use kind of very early days tooling there. Then I started to work with Consensus a lot more. So I started to work with Joe and everyone there. And I was doing apps and infrastructure with Consensus for about 4 years. And then after that point, kind of left Consensus. It was a very different, kind of company than when I had joined, and then wanted to basically tackle DevX and scalability for particularly Ethereum, because it just hadn't progressed in the way that I was hoping. And not only was proof of stake taking forever, but it was also just the space of and scaling and research, et cetera, just hadn't really moved forward. So I wanted to tackle that, and that's kind of where we started Fuel. Yeah.
Nice. It's funny that you got involved in the battlegrounds of Bitcoin development things. So, glad you came over to the Ethereum space, but there's no shortage of like hot debates here either. Like I'm sure you're aware of. But when it comes to Fuel, you mentioned that some of the things within the Ethereum community weren't going as fast as maybe you liked, and you saw some opportunities. So I would love to just get a high level overview of like what was the motivation behind Fuel before we get into some of the technical details of Sway and FuelVM and all that stuff.
Yeah. So basically, I've been to pretty much most of the DevCons, and at DevCon 1, there was a lot of conversations around the EVM, and just sort of how, well, it'll work for now. Like, we'll change it later. We'll just figure it out later. But right now, we're just trying to get things running. And basically a lot of the early Ethereum days was to just get it running. There was a big pressure to just get the network operational. And so, I think there was a lot of mistakes in its design from the get go because of the pressure they were under, and they just sort of made the best decision they could at the time. And there's no fault to anybody. I mean, they were just doing what they thought would be the right thing to do, and and it got the whole community to where it is. It moved blockchain forward significantly. But essentially, I've been having on the other side of it been trying to build things with Ethereum and build things with all these systems for a very long time. And you sort of, after a while, get pretty tired of looking at these kinds of systems that could have been a lot better. Or maybe if they'd just taken a little more time, they might have thought through a few decisions differently, and things would have been a lot better for everybody. And so, between that and also being a longtime user of Solidity, just kind of experiencing a lot of the issues that it's had over the years, I had a lot of sort of frustration and motivation to want to do something different. And I think once we were able to kind of instantiate the idea of optimistic rollups and realize that we could do a different kind of execution layer, but still be extremely aligned with Ethereum on values, and still be arbitrating and settling on Ethereum, and being very close to Ethereum, but just have a new opportunity to do a different kind of virtual machine architecture that didn't necessarily have to be backwards compatible. It just interfaces with it. There was just a massive opportunity to do something different, and to take a different approach. And so, between the kind of new opportunity that rollups and execution layers provide, and also just sheer frustration with the architecture of Ethereum, the EVM, the RPC, and Solidity itself, Fuel is kind of instantiated out of all of that stuff. And I think that's kind of where it stems from. Yeah,
that makes sense. Josh and I were talking off camera before you showed up about how, with Ethereum, it is now so large and there's so many important things running on it that it's difficult to iterate that fast when you're in that position, right? You can't just move fast and break things anymore, or ship new features and things and add new things to the EVM without really being scared you're going to break something, right? Because things need to be backwards compatible now. And what's interesting about this is this has kind of allowed you guys to iterate quickly on some things that you've probably been thinking about for a long time. I want to come back to this list of EIPs that there's like a list on the Fuel docs of like EIPs that were implemented in Fuel that haven't been implemented in the EVM yet. So let's say someone comes to you though and they say, all right, listen, I understand rollups. I understand like some of the stuff going on with zero knowledge proofs for scalability. Like, I mean, I understand you guys actually started off as an optimistic rollup. Like, I think the first like actual implemented optimistic rollup on Ethereum. Like, if someone comes to you now and says, where does Fuel fit into this ecosystem? Like, how do you describe where you're positioned to like the curious developer?
Yeah, I mean, I'd say that, and this will become more clear too as we release more architecture on, our bridge and where we're headed with Fuel. But essentially, we did release the first optimistic rollup to mainnet Ethereum. It's still the only, I think, trustless one, which is kind of hilarious. That is still the case. And I would say that where does it fit? It sort of fits in the sense of, what if you were to ignore everybody, take all the best research, look at all the virtual machines and all the languages out there now, and then just do something of your own, but with all those ideas incorporated? I think that's all Fuel is, really. Like, we're not, we're basically incorporating everything that the community has produced and other communities have produced, and trying to put together a system that is architecturally and from an engineering perspective what we believe is the correct thing you should do, and just sort of ignore the hype and the fluff and all that sort of stuff in the space, and just try to make the right call. And I think the byproduct of that is essentially what we did with Fuel itself, and how our processing model works, how the FuelVM works, and how our language works. Yeah,
makes sense. So let's get into some of the actual technical decisions you guys have made. The first thing is that there's this emphasis on parallel transaction execution. What was the thinking behind that approach?
Yeah, for sure. So a few things. Basically, the EVM is pretty bottlenecked onto a single core. Mind you, when Ethereum and everything was being designed, this was less of a concern because just multi-core, multi-threaded processing was not at the stage that it's at now. So, it's totally reasonable that at the design stage of where Ethereum was, that they just felt like, well, this is good enough, so we'll go with it. But basically now with modern CPUs and modern processing, being able to leverage a lot more threads and cores is really critical to opening up the total amount of throughput you can put through your system, and not just like transactions that are basic, but like sophisticated, complex transactions that do a lot of different computations. And so opening up the threads and cores of your CPU for transaction processing and validation is really, really essential. And most modern blockchains now that are not on Ethereum or that not are Ethereum or EVM based do this, and this is sort of the standard approach. And the main motivations there are you get a lot more throughput, you can do a lot more stuff, and mainly you can do a lot more sophisticated kinds of compute. So the kinds of applications you can do are far more interesting than the sort of vanilla applications you typically see, or just kind of more rudimentary computing applications you see with EVM systems. So multi-threading kind of gives you way more capacity and potential to do a lot of different things and a lot more things. So parallel transaction execution is a big focus for us, and we get that from our UTXO model, and we get it from our block and transaction processing model. Yeah.
Nice. That makes sense, and I think you're right in that you guys had the opportunity to look at things from a different perspective and actually implement something like that in a way that Ethereum didn't really have the chance to in the early days when they were just moving fast and trying to get something to work, like you said.
Yeah.
How about so on the way that the FuelVM works as well, it's also a register machine instead of a stack machine. What was the reasoning behind that decision?
Yeah. So again, when you just get to design things from scratch and you don't have to worry about backwards compatibility, you can factor in a lot more interesting designs into your system that we know can just provide a lot more performance. So stack machines typically use a lot more operations to achieve similar behavior to what a register machine would do. So register machines take up a lot less operations. And this is really, really key because unlike CPU architecture or general purpose computing architecture, those architectures are not priced, whereas blockchain virtual machines are priced machines. So every operation needs to be priced, and resource pricing actually ends up taking up a lot of your CPU, a lot of the actual compute itself. And so you have to be really sensitive to execution, particularly how you do it. And if you can optimize for less opcodes, you're going to get a better result on the computing side because less opcodes means less gas pricing. So really for us, we can achieve the same behaviors as typical Ethereum apps or stack machine apps, but we're going to have way less opcodes to do it. And this actually ends up being super beneficial because it just means less gas pricing and it means more efficiency. So really it's that simple. And this is like kind of known in computer science that register machines have less opcodes to achieve the same kinds of behavior. So they do have a boost in efficiency there. But really that's a key factor in Fuel's design. Yeah.
Yeah. So when it comes to having less opcodes, right? Is there anything there is this necessarily limiting in terms of functionality? Like, is having less opcodes remove any ability to do things you could do in Ethereum, or is it strictly just less opcodes to do the same stuff?
Yep, strictly just less opcodes and better performance. Yeah.
Nice.
Yeah, it's just they're typically register machines are typically harder to implement, and they're more strange and they're less common. So stack machines really easy to implement. It's like compilers 101 or like computer science 101. But register machines are a little more tricky because you have to use a few different techniques to really get them to work well. But when you do get them to work well, then they're fantastic because they're easier to audit, they're easier to look at, and again, they just use less opcodes to do the same thing. So yeah, it's all benefits down the line.
And what do you think about building languages for register machines versus stack machines? I mean, I guess if you're using like a sort of system, kind of like LLVM, right, and you kind of just write that back in one time. But
yeah,
what do you think about? Like, how complex is it to write a backend for a register machine versus stack machine here?
Surprisingly, all that stuff it really doesn't matter that much. An engineer figures it out. It's like really not bad. I think there's overemphasis on, or fixation. I think this is actually a problem within particularly the Ethereum community, because they've kind of made holy the EVM and the stack. It's like stack machine. But it's really like, I would just say that, from an engineering compiler's perspective, it's not a big deal. The main things are that you just have to think about things a little differently on the lower end, but still most of your compiler fundamentals are still the same. So you still have an IR, you still have a syntax, you're still just doing the similar security and optimization passes you typically do. It's just at that last stage, you're not going to a stack machine, you're going to a register machine. But it's really like, at that stage, not a big deal. And in fact, even a benefit, because register is just way easier to read, and they're way easier to analyze when you get like a string of them kind of coming out. So I would say it's, again, just benefits. Engineers just figure it out. Yeah.
Yeah, I've definitely noticed sometimes it gets really hard to reason about the stack when you're trying to step through stack machine instructions.
Yep.
But I mean, so kind of part of the reason that I bring this point up, though, in particular, and maybe we can get a little bit more into this, under the like sort of sway section of this, but I think kind of the idea with particularly like the Yule pipeline on the EVM was that basically any high level language could target Yule as a sort of intermediate language, and then basically we could all take advantage of the same optimizer, right? But in reality, it's not that, right? Solidity is just now migrating over to the Yule pipeline. Viper doesn't use it at all. Obviously, Huff doesn't use it. That's a completely different thing altogether. So do you think it's going to be a similar situation with Fuel? As of right now, as far as I know, there's only a single language for it, right? That's Sway. But as more languages do pop up over time, do you expect them to all kind of use that same pipeline, or do you think maybe it'll be a bit more fragmented?
Yeah, I mean, I think the vision for Sway is actually to be the blockchain language. So the language and compiler pipeline you'd use for all blockchains, not just for Fuel. So the broader vision for Sway is that it actually is a fantastic language to target something like Yule or the EVM. And it'd also be a good language to target Move or to target Solana. And the FuelVM is just where it starts in terms of its target. But the main idea is that we're seeing a lot of teams build and rebuild essentially a Rust-like language for blockchains, or some kind of facsimile language to target blockchains, when in fact, I think they probably won't maintain them. They probably won't care about them beyond a certain point. It'll be hard to tool them. And from our perspective, everything we do is modular, both in our conceptions of where blockchains are headed, but also in the conceptions of how the compiler will work. So all the security and optimization passes and backends, you'll be able to swap out, and you'll be able to put on your own syntactic sugar. So if you wanted to do a Python-like top end for Sway, so it feels like Python, but it goes down to Ethereum, you could do that, and you'll still benefit from all the advancements there. So Sway is currently working on a Yule backend, so it's happening. The idea there is again, if we're going to do all this work to build this language, we might as well make it as maximally flexible, modular, and useful for the community as possible, instead of just targeting the FuelVM, which is still niche, but is in our case easily arguably a much better VM than most VMs out there. Yeah,
I love the ambition there. I had not heard that either said by you and my research or the rest of the Fuel team. Maybe I just didn't look hard enough, but the ambition to make Sway something that is the blockchain, not I guess agnostic, like language that everyone uses. That could be really, really powerful, right? That is a good pitch for people to learn Sway, I guess, if people needed another one, I guess. That's fascinating. What I was gonna ask you is why build a domain specific language for Fuel itself, but it sounds like your ambition from day one was larger than that, no?
Yeah. Oh yeah, 100%. I think the thing is if you're gonna do a DSL, you do it right for your own system first. But in just doing it for blockchains in general, typically blockchains do share a lot of the same optimization needs and security path needs anyway. So really, just if you want to make it maximally valuable for everybody, that's sort of the way you should go. Yeah.
Yeah. I've seen you say, somebody actually asked this in the question I put out about what we should ask you. Someone asked like, when EVM, right? When is Sway going to target the EVM? And I guess one more macro question for you on that is how difficult is it to target these different environments, right? When it comes to the EVM, like the Cosmos environment, like what goes into that? on your end?
Yeah. Yeah, so there's kind of a few different factors. One of them is you do have to do a standard library port. So the standard libraries will have to be redone for EVM stuff because there'll probably be certain cases that just need to be met differently in assembly. But aside from that, you just have to switch the bit architecture. So our bit architecture is 64-bit, which is far more reasonable. Whereas, like, if you're going to target Yule, you'll probably have to switch that over to a 256-bit architecture. So the word size goes up, but that's just a configuration setting in the compiler. So I would say it's really not that bad. We are hiring people to do it because we do think it's extremely valuable. It also, I think, further demonstrates our like Ethereum alignment as well, which is just sort of a big piece of fuel. But yeah, I would say it's coming. And again, I think you're just not going to get a compiler of the same sophistication and kind of like clarity, structure, and safety as you will with Sway. So for us, like yeah, I think it's coming. Basically, the EVM stuff is coming, and it's pretty important for us as well. Yeah.
Nice. Yeah. Now we can get a little deeper into Sway here. We have some questions. So we've asked some people that are interested in languages here about assembly and the usage of assembly, and is using it something that reflects positively about language or not. And we'll follow up with a question about that in a second. But
yeah,
I think one thing Josh wanted to know, and Josh, feel free to rephrase this, but are there any particular uses for using Sway's inline assembly? I think Sway does have inline assembly, unless I'm just completely missing something here.
Yeah.
What would that be useful for in your view? Like, what do you see that being used for?
Yeah, so on the more like philosophical question of just using assembly, I mean, if a compiler is really good, you shouldn't really have to use assembly. So I think that's the first thing. I think basically, we'll work to ensure that you'll never want to use assembly in Sway unless it's really specific. So you shouldn't have to once the engineers do the rest of the kind of the normal optimization passes that we want to integrate. So I would say that's the first thing. But if you are going to use assembly in terms of why would you use it or why would you want to use it? Well, there's a few things. I mean, one is maybe there's odd case specific optimizations that you wanted to do that the optimizer isn't doing yet. So that would be a case for using assembly. Or there was just specific techniques you wanted to implement that were really high, like high sensitivity, and you just wanted to be able to kind of get in there yourself and just do some assembly over it. But I wouldn't say there's any like particular case that you should really be doing it. I think if the language and the compiler is working really well, there shouldn't be any significant gain to doing it. And honestly, the fact that teams like the OpenSea team went in and did all this assembly work just to be able to eke out some more efficiency on some of the implementations is kind of like the state of affairs with Ethereum, particularly when it comes to making things more efficient. Like, it's sort of sad, and Solidity should be doing those passes, or conceptually the language and compiler should be doing things that give you that result. So that's kind of the 2 cents of just using assembly in languages from my side, I would say.
Yeah. So actually, kind of two things here. Funny enough, you kind of already hinted at what your answer is going to be for this, but I mean, would you consider, at least in the context of VMs with like these priced opcodes and things like this, would you consider the usage of assembly kind of a necessary evil, or is it basically a failure of the compiler to actually like give you what you're looking for?
Yeah. So unless you're building a standard library, it's a failure of the compiler. So like, really, that's why would you touch assembly? You touch assembly when you're building a standard library over a VM, the specific case, and that's it. So that's why you use assembly, or you're a compiler engineer literally working in assembly. So I would say that would be the cases where you want assembly. And mind you, I've done a lot of assembly work. So like, I've done a lot of assembly work building multisigs. Like, I've on my GitHub like a 311 byte multisig that's EIP 712 compliant, and it's weighted. It's got all sorts of things with it. Like, Nick Dodson was very close to using it for ENS, but it just like didn't have the auditing, so he went with Gnosis Safe. But that could achieve the same exactly what you do with Gnosis Safe, but without all those contracts, just one contract. So I I understand the value of doing assembly, but I shouldn't need to do that. You know? Yeah.
Right. Yeah, that's it's funny. Actually, the person who kind of put me on to learning Sway and learning a bit more about Fuel, he gave me a lot of hell about that. He's like, dude, you shouldn't have to write Hoffman. You just shouldn't, right? But
No.
okay, well, but one more thing on this though. So I spoke with the Solidity team, pretty recently about there's a lot of discussion around this transient storage that is maybe getting pushed through to the EVM. The problem is, this is a new data location, and in high level Solidity, you have to specify like where your data is. So really, like what this would boil down to is, anything that you want to do with transient storage initially has to be done. It's going to have to be done through assembly. Like they'll support that in Yule, right? And you'll be able to do that in inline assembly. But in general, like you're not going to see like a transient data type for quite a while, I think. So, do you think? I think one of the use cases here is kind of being able to experiment with and try the new features of a VM or a language early. So do you see that being something that maybe would be a use case for assembly with Sway? Like let's say a new feature comes out and let's say it's just going to take forever to implement, right, on Sway. Maybe like assembly is kind of that bit in the middle. What do you think?
It should take like a day to implement the assembly needed in the standard library, and it should just be available in the standard library. I just can't see why that would take a long time. Again, I think that's a total failure of the construction of the language itself. It's really sad. Like it's a few other opcodes. Just using a bit of assembly, sure, you might need to conceptualize some things, but I don't actually think it's a big deal. Also, on the point of that, like the whole thing with us approaching those little things like transient storage and stuff like that, it kind of sucks too, because even with the FuelVM, we have different conceptions of things in terms of how memory works and stuff to allow you to not have to use something like transient storage, like particularly passing things like, you have a bunch of stuff written to memory in a certain case, and then being able to read that later in another call frame or another area of the execution. The FuelVM is really good at that, because the FuelVM just says we have a global memory read, but each call frame has local segmented writes. And that allows you to do things like, pass over a ton of data, or have more. You could literally have like a cross call, like consistent storage system if you wanted, and you wouldn't need to write all that transient storage stuff. So just by changing the designs of how the virtual machines work, given we know it's a resource constrained and price environment, you can just fix all of that stuff. So the FuelVM again just tries to solve all of that stuff for you, so you don't need to do anything weird like that. Yeah.
Right. Yeah. The global memory I think is really interesting. Like it's such a simple improvement, right? But it makes so much sense that you should be able to read memory from other contracts, sort of within that same frame. So I love it, man. I love it.
Yeah, and then calls also you just pass pointers, which is fantastic. So you don't need to re-serialize data across contracts, and you're still in the same stick of memory. So why are you doing that? Like it costs you so much money to just take the data, re-serialize the data, unpack the data, unserialize the data, put it into memory for each contract call, which is still in the same stick of memory. So again, this is like in a resource constrained environment, this is really bad. You might make some arguments about safety and stuff, but in that case, it's not really a good argument. So these are you start from scratch, you just get to redo it, and it's way better.
Totally. So on the developer experience side, like when you're writing Sway, what are some of the other greatest hits in terms of things you'd like to call out? I mean, I'd like to ask you about scripts as well, but I would love to just hear the high level greatest hits first before I dive into that.
Yeah, I mean, it's sort of the architecture and infrastructure of Fuel affects the way that the tooling works and affects what you can do on the user experience side. So it all kind of affects each other. But the FuelVM has a lot of nice things. So yeah, it does have smart contracts like you'd have in Ethereum. So they have storage and they have similar systems like that. So, all the same stuff you're used to. But instead of just making calls, you can make scripts. So this is something that is super great. You can do an approve and transfer from the same transaction. That's like the easiest one to describe to an Ethereum developer, to be like, that's one transaction now. So, that's that whole thing's gone. You can also do predicates, which are another kind of execution we have. So you can basically send a UTXO or funds to not just a contract or an account, but you can send them to basically the hash of a script. And if you meet the conditions of this script, then you can spend the coin. And this is something we inherit a little bit from Bitcoin pay to script hashes, but it also inherits from account abstraction. So this is actually what we conceive of as a form of account abstraction, because with Fuel, you can do some wild things. Like you can be spending funds in Fuel with a Solana key or a Cosmos key. Those are Ethereum tokens and Ethereum funds, but being spent in Fuel with a different kind of key. And the reason why is because you just have a predicate that says, if you have this Solana key and you show the right witness and you run it through this particular contract with this curve, then you can spend this coin. And so you can literally design stuff like that. And because as well, Fuel exposes the entire transaction in memory upon execution, these predicates can restrain what the transaction is that's going to spend it. And so you get to do all kinds of crazy stuff with that. So you can do accounts that are like multi-sigs. You can do accounts that are like Solana accounts or like Aptos accounts, for example. You do all kinds of stuff like that. But there's no hard forking of the system. You can do new curves and new maths and smart contracts, and it's pretty wild. Yeah.
It's fascinating. Yeah, I think so on the scripts though, hang on. Like, let me back up on the scripts thing, because like that's going to be new to a lot of people, right? Being able to batch those things together, just like as a part of interacting with the FuelVM. Can you go a little bit deeper into how like the scripts themselves work?
Yeah. So basically, just like an Ethereum program, you would write a program which is just a single function, and when you post your transaction, there's two kinds of transactions in Fuel. There's creating smart contracts, and then there's so you put the bytecode in, it creates the smart contract, and then you have a script, which is just posting the data of a program that just runs when the transaction's posted. And the script can make calls, so it can make calls to contracts. It has unified memory execution environment, so you can make a bunch of calls, do a bunch of math, consider a bunch of factors, do a bunch of other calls, and basically, it allows you to kind of do all the nice user experience things that you'd like to do that you can't do. So, for example, with Uniswap, a lot of the contracts are routing functions, and you kind of see that in the way that they work. But if you just had scripts, you wouldn't need all these fancy routing functions. You would just need the endpoints of what you want to affect, and then you'd just be deploying scripts that can just go in and do the things you want to do. So unlike Ethereum, where you have to throw things through a bunch of single message sender like transactions, and go to a smart contract and change the delegate, change who's calling what with things like delegate call. With Fuel, you can just do what you want to do with scripts. Yeah.
Cool. Yeah.
So making sure.
Sorry, I was just going to say the UX implications of that are fascinating. But go ahead, Josh.
Mm-hmm.
Yeah, no, this is a really, really interesting idea. So a couple questions on it. So one, just making sure I understand. This is a piece of bytecode that gets deployed to the chain, and then it's executed, and then it's dropped, or does it stay on the chain for other people to interface?
It's prunable. Yeah. So if you want things to stay on the chain that other people can interface, that's a contract. So you just deploy a contract for that. Yeah.
Gotcha. Okay. And so, and I assume like any let's say any computation that happens within your script that isn't explicitly a contract call, that's all payable with gas?
Yeah, so you still have a similar kind of gas metering that you would do with Ethereum, but we do get to do some gas pricing. We can basically do different styles of gas pricing, but you could just imagine it for now, for sake of understanding, just that it would be similar to Ethereum. So yeah.
Awesome. Yeah, I really like the idea of scripts. I think that's going to be a big one.
For sure. Yeah.
So on gas pricing and paying for transactions, you guys have a really interesting model for native assets. Like you can basically initialize other native assets and use other assets as native assets and use them. How does that work, right? Because when I was first reading your docs and things and thinking through that, like, is that meant to be the analog on Fuel for like an ERC20 token? Are tokens still meant to be contracts? Like, how do you can you just explain the native asset bit and how that works?
Yeah, for sure. So with Fuel, basically, every smart contract you deploy can mint its own kind of token. And that token can basically be spat out. It's a fundable token. It can be spat out of the contract and then become UTXOs. So the reason why you want this and why it's really good is with typical blockchains, you do need to pay fees. So you do need a native asset system to be available to do things like paying fees. In this case, it'd be paying the block fees. So that's the first thing. But the second thing is you want fungible tokens to be able to benefit from all the native optimizations you get from a blockchain client. And so in Ethereum, only one token gets native benefits on transfer, which is Ether. And it just sucks because you're sitting there and you're going, well, why is it 21,000 gas for me to send Ether around and then to send a token around, which is functionally very similar to anyone else, it costs far more. And the main reason why is because you have to deploy a contract, you have to account for all the merkleization in the contract and the stake costs and everything, and then it basically just hampers the cost of doing fungible assets in the blockchain itself. So with Fuel, smart contracts can mint their own NFTs, burn them, and create them and shoot them out of the contracts. And it gives the developer a lot more feature functionality for creating fungible tokens, which is a huge portion of what blockchains are for. And so all tokens get first-class properties in terms of processing and fees. So it's a really nice value add for just tokens themselves. You're going to experience a lot of cheaper fees because of that. Yeah.
And so what about what about like, let's say, a special functionality in tokens? Like would I be able to create a native asset, let's say, that has like flash minting or maybe some other like custom logic that isn't necessarily just mint and burn?
Yeah, so the smart contracts can mint and burn these things internally within the contract. You can design whatever you want. So you can design whatever accounting mechanisms you want internally as assets enter a contract. But when the assets are taken out of that contract state, you can literally think of it as the asset is leaving the state of that contract, and now they are an atomic token piece that is sitting in the chain. And this gives you this basically reduces the cost significantly. You can still build a vanilla ERC20 token or 721 token in Fuel the way you would do it with Ethereum. But the thing is, developers will get another API, which is this native asset API. They can shoot these tokens out of the contract. And then basically the tokens are free to be fully transferable, but they're simple. They're just atomic UTXOs, similar to what you would see in Bitcoin. The difference being that when they're sent out of the contract, you can do some weird things like send them to a predicate, which might constrain the spending conditions on that UTXO potentially forever. Because the spending condition could literally say, you can spend me if you recreate me again as another thing that has the same conditions. Like you can do some really strange stuff like that. And that allows you to create some pretty wild designs that, again, on the state side, which is very important for blockchains, is extremely minimal. So the state processing element of doing native asset transfers and doing predicates is very small. It's literally one read write out of a database, so it's fantastic. Yeah.
Right. Yeah. I mean, I don't want to jump the gun or anything, right? But I think I definitely don't see this sort of like contract token really taking off the same way, in Fuel that you see in the EVM, because in the EVM, like you don't really have an option, right? Like you have to do an ERC20 token if you don't use Ether. Whereas like, here I mean, you would basically need some kind of callback system or, this sort of approved transfer from pattern, right, to even get the same functionality. So I think that's a pretty good design choice there. I think like having other assets.
And not just that, when you make them native, you can do some other strange things. Like you can literally put them through the call. So if I call a contract in Fuel, instead of being able to just push ETH as value, I can push any native asset. So just think of all the reduction in complexity that gives you when you could just make a call and shoot a token into a contract, like of any color, of any kind, So it changes the way you think about tokens because now across all the call system, that's available to you as well. And so it's another way for tokens to enter contracts. And then transactions can feature many inputs, many outputs, so many different kinds of tokens in and out, with many different kinds of witnesses and different kinds of spending conditions. So really, Fuel's transaction design is fantastic for this as well. You can have a transaction that just pays like 200 people with 200 different kinds of tokens. You could do that in one transaction. It's like really cool. That's a much nicer design. It gives you a lot more flexibility as a developer than what Ethereum would typically do. Yeah.
Super cool. And then, so when it comes to these native assets, can you also pay for like transaction fees in these native assets as well?
Yeah. So right now, all the base sort of system we're going to ship will be paying fees in Ether for various reasons, like cryptoeconomic reasons. But you can, there is a way to spin up private mempools, and private mempools will allow you to basically send transactions for whatever fee. As well, you can also do some strange things like, if we can get order book systems on Fuel really nice, there could be a case where you send a transaction to an order book first, it gets processed there, and then in the processing of that transaction, they swap it out for fees, and the block producer gets paid in what they want to get paid in, but the fees are still paid. And as well, there's some odd designs that we have where, because we're a UTXO based system, you can do some really cool witness states where you have partially signed transactions. So one party can sign a piece of a transaction, the other party can sign another piece, and basically complete it. So you can do some wild native meta transaction stuff.
Yeah, super cool.
So that should alleviate that as well.
Yeah, I wanted to ask, just because, yeah, you're exactly right. The crypto-economic security would get very weird if you could just mint some iteration of Shiba and use it for transaction fees. So
exactly. Yeah. ETH is the best so far. Yeah.
Yeah. With you there. So, okay, we talked a lot about the comparisons to the EVM. We also talked about transient storage a little bit ago, which is one of the things that there's an EIP out for. It's been hotly debated, but you guys just implemented. There is that page, which I will link in the show notes, to list of EIPs that are yet to be implemented that are alive in Fuel. Are there any other greatest hits there you'd like to call out in terms of things you guys have implemented that you're proud of?
Well, I mean, there's just so many things that make Fuel particularly a really interesting blockchain and an interesting environment to develop in. But I would say the big key ones are things like multiple native assets, scripts, predicates, akin smart contracts, and then things like account abstraction, much better DevX across the board, and numerous benefits in terms of just how the whole system is architected as a whole. But yeah, I would say that's what comes to mind right now. But there's certainly a lot of things. Yeah.
Makes sense. Yeah, I mean, I think if people are curious, they can go to that page and just see some of the comparisons.
Yeah.
One question for you that some people might raise is either criticism or pushback on the things you're saying, because I mean, Fuel seems great. I've experimented with Fuel. Sway seems great. I've experimented with Sway. Fuel seems great. One thing that Solidity has is a lot of auditing firms. It has a lot of security experts, people that have seen things over and over again. How do you think about smart contract security when it comes to Sway and what you're working on? It seems like Rust, the Rust inspiration there probably helps with this, but would love your take.
Yeah, so it's a few different levels. So the first one is, because we redesigned the virtual machine, we designed for removing all of the nasty edge cases that present a lot of the security problems you typically see with Solidity and EVM. So that's the first thing. So the virtual machine, by construction, is much safer. There's a lot less edge cases. Every opcode's been designed in such a way to factor in these kinds of edge cases. So that would be the first thing, is the architecture itself is much more conducive to a safer build and a safer environment. So that's the first thing. The second thing is, on the language side, the compiler is being designed with all of these security lessons in mind from what we learned from the EVM, but also to play off of the design of the virtual machine. So we are very lucky that we get to look at what's happening in the space and make modifications to the virtual machine or the compiler at the same time, to to be able to give us a safer system. So like, for example, we modified our storage opcodes to basically tell us, is the value I'm getting out of a contract storage 0, or is it instantiated or not instantiated and the value is 0? And that little difference would have factored and filtered into the language, which would have prevented something like the Nomad hack, for example. So those little things we get to do that you don't get to do when you're designing with backwards compatibility in mind. So so I would say that on the level of safety, the compiler, by virtue of like its Rust design and Rust philosophy, its closeness with the virtual machine that it's building for, and as well just the ability for us to make these kinds of changes makes the whole thing a lot safer. And even having things in the standard library like reentrancy guard right away, and then having the compiler warn of reentrancy would have prevented a lot of stuff. And then lastly, on the auditing firm side, we already have 3 or 4 auditing firms already that are basically on the sort of sway pill already. And I would just say that all of that stuff isn't really an issue. It's more like the auditing firms. There's, first of all, a lot of them now, way more than there was before, and the market's completely shifted than it used to be. And auditors understand Fuel and Sway way more than you think they do. It's just more or less that if they're presented with Sway, basically the auditors that we are partnered with would probably be better than the ones that we haven't yet. But there'll be a lot of auditing firms that will just audit Sway because of our attention to detail on the security and design side. Yeah.
Yeah, I mean, part of that's just a function of demand too, right? If the more contracts deployed on Fuel, the more there will be demand for auditors that learn Sway. So the market should help you there.
Yeah.
So I'm kind of on that note. You guys care about developer experience a lot. I actually talked. We had Cami on the podcast to talk to you a lot of DevRel developer experience stuff a couple weeks ago. She's fantastic, right? But what do you hope people build on Fuel in the next 6 to 12 months? Are there any libraries or tooling you hope that the community builds you'd like to call out?
So surprisingly, most of the math and crypto libraries that I would like to have seen are already built. And it's rather shocking that it took that little time. So now we're in a place where I think all the current DeFi primitives can be constructed, and NFT primitives, whatever we want to put into the market. From our perspective on the project side, we definitely love to see a few really strong DEXs, a few really strong lending systems. No one's yet to crack the building of Compound or Aave on our system. It'll take like 2 weeks, but it'll probably not take very long at all. But basically, these things are, lending and DEXs are probably the first thing on the DeFi side. On the NFT side, we already have quite a few examples of NFTs and NFT marketplaces. So I would just say that in terms of the next 6 months, it's going to be building and stabilizing good DEXs and lending systems. And just kind of restarting a sub ecosystem of that sort of stuff on Fuel. And with Fuel, we don't care about having thousands of projects on Fuel. We'd prefer to have a few really, really great projects that actually give a shit and that want to produce both a system that's unique with Fuel because of the way that our system works, but also that achieve the same things that we do with Ethereum, but just do so at a way cheaper way and probably with way more interoperability opportunities like between the systems. So doing things like flash lending on Fuel is going to be way better and way different than doing it on something like Ethereum. So I think these are the things we'll see in the next 3 to 6 months that I'm pretty excited about. But yeah, philosophically, we don't need to see like a massive ecosystem of NFT projects that like half of them are probably rug pulls and just mercenaries that don't matter. I think it'd be cooler to have more real Ethereum projects come in that want to see the benefits of Fuel, and then have some really great projects that actually give a shit and that want to push the boundaries with what's possible with blockchains. Yeah,
I think that's the right mindset to have for sure. Josh, you want to add something?
Yeah, no, I really like that approach, man. I feel like it's just about everything out there, right? It's trying to push like, look at all these projects we have. Even I hate to do a call out here, right? But even the Aptos, right? Like the ecosystem picture that was just like hundreds of these things right on launch, and it's like, okay, that's cool, but how many of these are getting used? Like how many of these, like, like what's really pushing the boundaries, and even just taking advantage of that system to its fullest potential, right? I mean, there's some unique things going on with these move blockchains, but that you could kind of take advantage of. But yeah, I'm really looking forward to seeing some of the weird and funky stuff you can pull off, with the FuelVM.
Yeah, and I'd also say too that like I've talked with some of those projects, and basically with about 5 minutes of conversation about Fuel, they'll just build it on Fuel too. Like there's no allegiance at all. It's not like Ethereum where projects have this principled mindset and almost religion about what Ethereum is and what Ethereum means and how they experience things and how they build things. It's very, very different. So those projects are ripe for coming onto Ethereum through things like Fuel. And I also think too that a lot of the actual volume users and things happening in the space happen on very, very few places. So probably just Ethereum, things like Polygon, probably a bit of Solana, and that's it. It's really very small. It's not a lot of volume. So yeah, that would be my 2 cents.
Yeah, the really large ecosystem pages can make it look like there's volume when it's not necessarily there. Even TVL can be gamed, right? As we've seen.
Yep.
Okay, so one thing that I can hear some people asking right now is, all right, like this all seems pretty awesome, but like, is there like a catch, or is there like a drawback somewhere? So like if somebody came to you like very skeptical and was like, hey, what is Fuel not right for? Like, is there something I'm missing here? Like, is there anything here that would prevent me from doing some kind of application that I want to do? Like, I guess what I'm asking is, could you, as someone sitting in your shoes, as like the guy who's helped build a lot of this stuff, can you make any kind of bear case or speak to any of maybe the drawbacks, if there are any? And if there aren't, saying it's all amazing and it's all just better in every way is a valid answer. Just, maybe a little bit of a justification as to why that is would be good.
Yeah, I would say my answer there, because it's very easy for me to to come up with a few answers for that. Namely, because there's only 2 or 3 things I can think of, which is basically with Fuel, we spend a ton of time on just the engineering and the principles of what we're trying to get done. So we're coming from the Ethereum ecosystem and all of the work and the research that's been done there, and we're building a better system. That means that it's not going to be compatible or interoperable with what you use existing. So you have to rebuild everything. So you already have to be kind of a glass eater to want to do this. You'll have to rewrite things. You'll have to learn some new things. But you're learning the cutting edge of literally everything. So you have to remember that we factored in all of the designs. So the MoveVM, Solana, Wasm, MIPS, like EVM, everything into this system. It's designed with many, many different intersecting factors in mind. So you're getting the best, but you're going to have to glass eat a little bit. Mind you, most of our engineers, like something like 55 of our engineers, work on DevX only. So basically, the DevX will reach a point where it'll be significantly better than your most premium experience you're going to get on any other blockchain. And they'll just keep getting better and better and better. Like they'll get more cohesive and they'll get smarter. And the developer experience will be unrivaled, probably within like a 6 to 8 month period. It's already better in many ways now, but it'll get much better. So we're just spending all of our money and time on DevX, basically. And then in terms of the negative bear case for a project is, yeah, you're going to have to glass eat. And then secondly, if you're just looking for, kind of VC funding and BD, and that's what you're designing your project around, then building on Fuel is going to be tougher for you because this is a new kind of execution layer. It's a new kind of zone on Ethereum. And it's not going to have, it's not going to have all of those projects just floating around beside you. So when you're building on this stuff, you're building on it because you genuinely think you can leverage the tech in a different way, and you philosophically believe this is the right thing to do. And I think that's really that's the harder choice you make. But the projects we have on Fuel are way more ideologically and philosophically aligned to that. And we're way more happy to have them because, if you go build something for the EVM or some of these other ecosystems, like you basically just totally locked in. Fuel gives you an execution layer approach, which means we can deploy other execution layers with different security properties and configurations that give you a lot more options as a developer. But it'll take some time for us to get to that. Yeah.
It's a very good answer. 55 DevX engineers. Holy shit. That's wild. That shows priority though. I mean, God, it makes sense, right? I mean, I don't know if it's easy to see like how many engineers are working on what at different projects like this, but that seems like it makes it very clear what your priorities are. And I think that's really cool.
Yeah. And things like the docs and the DevX experience will continue to improve every day. Like if you're using Fuel right now, it's like rapidly breaking because we're rapidly just like adding and changing things. But it will get to a point where I think it'll just be like an exceptional experience to ship something. And it takes a lot of effort and time to get to that point. But basically that's sort of what we're aiming at. We have very like clear vision of how we'd like that to happen. Yeah.
Very cool. Okay, I think that's all the questions I have on Fuel. I don't know if Josh has any more, but as we wrap up today, I'd love to just ask you a couple questions personally about your engineering career and how you like approach getting better and all these different things, right? So one thing we like to ask people is like what have you done throughout your career to level up as an engineer? I mean, obviously you've worked on a lot of different things, but would love any advice you can give to people that are looking to get better.
Yeah, so I mean, I'm really a hacker. Like, I'm a philosophy dropout and a musician. So I'm not going to be the best to give you conventional advice about computer science. I've sort of learned everything I know about engineering and computer science because I wanted to do something. And to get to doing something, I had to learn all that other stuff. So for me, I come to things in a very strange way. And the way that I code is much more lone wolf and emotional than it is in like an analytical way that you would do a large social coding project, even as Fuel is configured now. So I would say that you have to realize, are you an analytical, like read a book kind of coder, or are you someone that has to go in and experientially find your way through things and like experience how the system works and then kind of get a better sense that way? So that'd be the first thing. And then the second thing is just trying to ignore as much noise as possible and follow your curiosity. So the more curious you are and the more persistent you are about pursuing your curiosities, it's going to give you a much better chance at learning some pretty wild stuff that will actually end up either getting you hired or building your next project. So I would just say like, I learned all this stuff because I was very curious about what was possible. Like, could you build some kind of layer on Ethereum that could transact, but that retained the securities? And that was sort of the question you ask. And the answer is, well, yes, in theory, but now you got to go do it. So then you work with a few people and you actually go do it. And then you go, okay, wow, now that's possible. So then what else is possible? And in doing that, I picked up a lot of computer science, like just even doing that. Even just being around John, you pick up an immense amount of computer science. So I would just say like your curiosity is your best sort of weapon to becoming a better engineer. And then just you have to stay super persistent and be ready for bazillion bugs and trial and error. And then nothing is really wasted time. Like if you spent a bunch of time making a really dumb game, but in order to make it, you had to learn a bunch of insane things, it's not wasted time. So like you'll go use a lot of that stuff in your next project, and in the next project you'll be amazed at where it surfaces. And you'll be like, oh, well, that's actually easy for me. So I would just say it's like persistence and curiosity would be your biggest weapons there. And that's at least how I approached it. But I came to these things in a very unconventional way. So I really shouldn't be doing any of this stuff. I just am. I just find myself in these positions, and then now it's like, okay, well, you can put your own spin and take on it. Yeah,
it's really, really cool. Is there any bad advice out there that you see being given to either people like yourself or younger engineers that you just think people should be more aware of? It is bad advice?
Yeah, I mean, I think it might not be advice, but just like, oh, I'm gonna go work for Google at Amazon to have that on my CV so I can go get hired somewhere. That would be bad advice. You should look at the world and what you're capable of, and then look at the most exciting thing you possibly work on, and then go do that. And if you can't get hired for it, then learn how to do it yourself and build some facsimiles of it, put it on GitHub, and then go get hired, because then they'll hire you. So it's really not complicated. It's just, if you do boring things, you better have a really good reason to do boring things. Or if you do things that are like conventional, you better have a really, really good reason. Otherwise, you should go seek out the highest value things you could be doing with your skill set and your time as an engineer, and then learning and doing those things. Yeah.
That's really interesting. Don't resume pad, follow curiosity. I like that.
Yeah.
I like that. Awesome. Nice. So final question. We ask this to everybody, right? This is way more high level, but what do you hope over the course of the next decade or two that we accomplish as an industry? What does success look like in the macro for you, if you've thought about that at all?
Yeah, in the macro sense, it's pretty simple. It's just philosophically speaking, and I am a philosophy dropout, so I'm kind of a professional at this. Philosophically speaking, the most poignant thing we can do with blockchains, and the reason why it's important, is because it's a system or primitive that exists outside of corporations and governments and nonprofits. So really, these systems are networks which potentially exist at a global level, so outside of a particular region or country or whatever, that can be immensely valuable for human beings. So when your corporations or your government fail you, you'll have these things available to you. And I think at a very, very basic level, that's how it can serve all the people on planet Earth, is just being another order or primitive or protocol above our existing social protocols. So I would just say that if we're successful at that, it would just be that if over the next 5 or 10 years, 3 or 4 governments collapse and a bunch of people leave those countries, and we're able to get their money out because of crypto or their wealth or their value, or be able to still continue on even under collapse, then the system has served its purpose, even if it's just a few people. So I would say that would be the most maximally valuable thing crypto can do, other than just recreating existing financial primitives, but outside of regulatory spheres, etc. I think the real core of it is there's something philosophically very, very different about this, and you feel it. You might not be able to express it, but you certainly feel it. And so I think that would be, from my perspective, the most important or valuable thing we could do. So just having that fail safe for people, just in case a bunch of corporations or a bunch of governments fail them. Yeah.
Nice. Amen to that. Well, Nick, thank you so much for coming on.
Cool. Awesome.